A gas sensor is a device that detects the presence of one or more types of gas in the environment. These sensors have wide applications such as security systems of refineries, industrial centers, and even homes. These sensors can detect combustible gas, toxic gas, pollutant gas, and so on. There are several methods for gas detection. The most commonly used is electrochemical sensors. These sensors measure the concentration of a specific gas by performing a chemical reaction on their heated electrodes and measuring the resulting electric current. The MQ9 sensor is sensitive to carbon monoxide and flammable gases. It can detect the carbon monoxide density from 10 ppm to 1000 ppm and the flammable gases density from 100 ppm to 10,000 ppm. MQ9 has an internal heater that starts warming up if a 5 volts voltage is applied. The internal resistance of this sensor changes as the density of the detectable gases change. This value can be read by a simple circuit. MQ9 sensor modules in the market have already implemented the necessary circuit and you don't need any extra item. The MQ9 sensor has 6 pins called E, B, and H, 2 H pins for a heater, and 2 pairs of E and B pins for pad. To turn on the heater, just connect the H pins to the VCC and the ground. The heater consumes less than 350 mA. For pads, you need to connect both E pins to 5 volts and use pin B to get the output signal. It's recommended to pull down one of the B pins with a 10 kΩ resistor. The output signal is analog and changes with the amount of the ambient gas. It's much easier to use the MQ9 module instead of the sensor. The module has only 4 pins, which are VCC, ground, analog output, and digital output. The digital output pin will become 0 or 1 based on the amount of the potentiometer connected to the op-amp on the board. The required materials for setting up the MQ9 module are an LED, a 220 ohm resistor, a mini breadboard, and some jumper wires. And as a microcontroller, our choice is Arduino Uno. You can buy all these parts from the Electropeak online shop. The wiring of this circuit is very simple. We use the regulated voltage of the Arduino to feed the module. Just connect the analog output of the module to the Arduino analog pin 0 and the digital output of the module to the Arduino digital pin 6. And finally, we connect a pull-down LED with a 220 ohm resistor to the Arduino digital pin 2. Take a few points before using the module. The MQ9 sensor needs at least 24 to 48 hours to warm up and get ready to use. Don't put the module in wet or very cold places, otherwise you will not receive the correct data. Long time exposure to very high concentration of gas may have negative effects on the sensor. Shaking the sensor or exposing it to waves such as ultrasonic may reduce its accuracy. Don't feed the module with more than 5 volts as it can damage the sensor. We have to calibrate the module before using it. This sensor measures the gas concentration based on the resistance ratio. To calibrate the module, we need to calculate the R0 value in the clean air. Open the Arduino IDE to write the code. In the setup section, set the baud rate to 9600 for serial communication. To obtain a more stable data, read the analog A0 pin value 100 times and get an average of these values. Convert the sensor's analog value to the voltage by knowing that the Arduino ADC resolution is 10-bit. Calculate the RS air value according to the resistance on the module. In most modules, this resistance is 5 kΩ. Given the table in the datasheet, calculate the value of R0. View and write the R0 value in the serial monitor. And now the final code. In the setup section, set the baud rate to 9600 and define the LED and DO pins as output and input respectively. Calculate the RS as the previous code. Get the R0 from the previous part and calculate the RS to R0 ratio and show it. Read the digital value of the sensor and turn on the LED if it passed the limit. The next step is yours. Try to measure the amount of gas in ppm and display on the terminal using the ppm graph in the datasheet. To do this, you should get the graph function and add it to the code.